Assalamu alaikum. Welcome to Untitled channel. Today we are going to describe SDN switch and VLANs. Regarding the VLANs and the switch configuration, how the switches are working. These things which we will describe, this you can see it's in white color because VLANs are virtual and this SDN software defined. There is no hardware defined. It's a software defined means it will be located here and located 20 km away in the same VLAN. So that is called software defined network managed and controlled by the two servers. These two servers, I will explain you the architecture of the big switch. Here software defined network has components, they are grouped together and the whole group of components is called pod, P-O-D, pod. So big switch is referred in the environment as a big switch pod. This is BCF and a big cloud fabric controller. These controllers are nothing but one-use servers which are running an operating system from the big switch, and the two are in standby and active standby mode. So, and they are connected to spines. These spines are again switches, and these switches are connected with 100 gigabit or 40 gigabit uplink ports from the controller. These spines are later on connected to leaves, lower portion of the switch end points, which are having double connection to each switch and to the each spine. So there is something called, this kind of network is called mesh connection. That is called mesh connection. So they are in mesh connection. So even if any of the cable fail or any of the component fail, any switch, any leaf fail, you will not have any disconnection. These switches are very good. Performance is absolutely good. We have good experience in these switches, big switches. Now they are in another ARISTA company has taken out these big switches, and all performance is very good. So remember that at the end there is group of leaves. You should not mix two interfaces or from a same server to two different group. No, the server must be connected to same group. Then you will have a redundancy. Then you see one group 2 and group 1. This server is connected to group 2. This server is connected to group 1. So this is very important point to be noted. And these are also called TOR switch. When you go into technical terms, there is TOR, connected to TOR. That what is meaning by TOR? Top of rack switch. So this is called TOR. And virtual VLAN means that those are created on these switches. And these servers are physical servers, HP server, Dell server, any server, and they are connected with 10 gigabit or 25 gigabit ports. Whatever you have interface, you are going to plug it. And 40 gigabit also, 40 gigabit, 100 gigabit as per your availability. Now this is pod. Remember this infrastructure which is having two controllers, two spines and number of leaves. Number of leaves are connected in mesh connection. Every server will be connected to every single group of leaf. Do not mix two groups into one server. This is advice. Second thing, what is VLAN? Very interesting topic. Whenever in a classroom, when teacher says all boys stand up, everybody gets stand up. Why? Because the speech is being broadcast to everybody and they follow the things. Now, in order to reduce the broadcast domain, there is a new technique, actually it's a word, which is called virtual LAN, VLAN, VLAN creation into the switch. The broadcast was in hubs. Hubs are replaced with the switches, and now these switches are having multiple VLANs, and VLANs are extended from one switch to the other switch, and now these VLANs are coming into software defined network in different way. Now see, suppose here is a switch and I am having ports, and if I create a VLAN blue between two ports and VLAN green into the ports, so the information which has been passed to this VLAN will not go to this VLAN, because these ports are isolated by VLAN. So this kind of separation is called physically red block is a switch, but these are virtually separated and these are called virtual local area network. So this is virtual area network. What is the tag port and what is untagged port? For example, this port is completely separate. It does not have any VLAN, so it will be in default VLAN. Always default VLAN is 1. So this port is untagged port, not given any other VLAN. So it will be untagged port. Now, a specific port which is there into the VLAN, it can be tagged or it can be untagged. When the tag comes, a tag will appear when you merge two different ports into a separate VLAN. Yani, if you merge these ports into two different VLAN, then this port, say 1, 2, 3, 4 and 5. So the port 3 and 4 are into one VLAN black, and they are also 3 and 2 are part of green VLAN, and 4 and 5 part of the blue VLAN. So now this 3 and 4 they are tag ports. So it will be member of two different VLAN and it will have information of both VLANs. Now untagged port, as I said, okay. VLAN ID. Every VLAN is been assigned with an ID. Whenever you say anything for VLAN, so VLAN 10. So what is this VLAN 10? 10 is not VLAN 20. So these are the IDs. These are called ID. When you define a VLAN ID is been assigned. You can name this my VLAN, my class room VLAN or whatever. But the ID is based on this number. So whatever number which you give, that is the VLAN ID. Whenever you are passing the traffic, it is going with the ID. So be careful. So this is called VLAN ID. Next, here, I think now it will be much more visible to you. This is actually the VCF infrastructure. When you connect to VCF infrastructure, you will find like this. This is active node. One node is active, another is standby. So these are the two top controller. Below the controller, these are controller. Below the controller is the spine switches. These are the two spine switches, SP01 and SP02. Below the two spine switches, there are leaf switches. These are the C, and this shows you the different speed of the port on the switches, leaf 1, leaf 3 and leaf 2, leaf 4. This here you have seen showing group 1, here it is showing leaf group 2. So this is very important. Do not mix. So whenever you are giving connection to the server, you have to give F11, F3 and F2, F4 separate to different servers. So Here there are so many things: logical, edge, visibility testing, integration, many profiles of in the fabric submenus are there. So this is the one which I am showing you the how the interface looks like. Now here this big switch has been taken over by ARISTA company, new company, and the programming of big switch is like this. I will just explain you. You can understand easily, and okay, I will zoom it here. Just normal switches, like you have to put the enable command, configure command, and here the things like in other switches, these switches are having tenant policy, something called tenant. You see tenant, so this is the name of a tenant. You have to assign tenant in a pod. You can have multiple tenants separated. The tenant can talk inside the tenant. You have to delegate the relation to talk to the different tenant or not, just like a VLANs. In that tenant, these are something segment. The segment is nothing but called same as VLAN. The concept of VLAN in the soft switches is here, the segment. I have given the segment 222, means this ID is the 222 ID of the segment, means VLAN ID. VLAN ID is 222. Now, when I want, after that, in the VLAN, how we add the member? Same way in the segment, you are going to add the member interface group LB01 VLAN 222. This you have seen here is a group, interface group. Very important. In other switches, when you want to configure something between two different switches to give aggregate traffic increment and also redundancy, so that is called trunk. That trunk into the normal switches, but here the trunk is called as interface group, and this is one group formed. This group, how the group is formed? This way, and the mode is called LSCP. This LSCP mode for LB01 group, which is showing you, suppose, and this group is member of this VLAN or this segment. So these two interfaces, 33 from the switch 1 and 33 from switch 3, these two interfaces are part of this VLAN, in which there are two more ports. One is untagged, another is tagged. This tag port is lead by 222, the number of VLAN ID. This is that 222. And what you see here is a 222, means this is part of this VLAN. Now I will explain you how the thing is happening into the trunk. Here what you have seen is 33 port number. Suppose this is port number 33. Oh, no. Suppose this is port number 33 and this is port number 33. This is leaf LF01 and this is LF02. I prefer to put my finger here. This is the one, and this is on two ports 33. This is LF01. This is LF02. Port number 33. Now, these two ports I have configured as they are LACP. So, what does it mean? I am going to make them as a group LACP. This is from So this should be 3 here, 3. This is very important. No mixing of the group. One group means one group, leaf 1 and leaf 3, same group. This LSCP and it is saying load LB01. So here is my port on load balancer. Load balancer 01. So it is called LB01. So this LB01 will have a redundancy. Even if this switch fails, it will carry out its traffic from this switch, and also it will have a trunk port. Even if this port fails, it will carry out traffic from this port. So this is giving you a redundancy, as well as the bandwidth will go double. So this is the one what I wanted to explain you. This is, in this it is called group, but in the normal switches it is called as trunk port or LSCP. So this is the one which I was going to explain you, and now you can understand this is what is trunk and what is LSCP carried out. I would like to explain one more thing, that in my previous lecture I had missed something about the people had asked me, commented me, you have not explained anything about the NAT. Network address translation. It's very easy. My internal network is 192.168.0.100 or 0.11. So I will have a one-to-one NAT on the other side, when it will be mapping to, suppose, 213.42.40.11. These are the things. Usually in the public IP, these are the public IP, these are your private IP. You can NAT to the public IP whatever is required. You have the bank. Here you will assign whatever, automatically the NAT is created onto the switch or firewall. So it will automatically translate into that number, and it will go outside with that number. Policy will be created. This is preset NAT is there. There is another NAT which you are using for internet browsing and something. So those are using a one IP to go out. Suppose you have IP 213.42.11.11 to go out. That is called PAT. So for internet traffic to go out with this IP address from your router, you have your internal network, which is this one, 192. What happens onto the router? Any traffic from the browser, here it will be addressed up to 224 or 254 up to the end, or whatever are there. So these all IPs are clubbed together into a table that is called PAT table, port address translation. Suppose the traffic from 11 and 12 and 14, .13 and .221 is running. So what this will do, PAT, port address translation, it will generate a traffic by this interface using a separate table for IP with, suppose, 64001. Here will be one port assigned for this, and it will send the traffic to this IP. Now, if it is opening another browser, it will have another table with 64002. So this is browser number 2. Maybe one Internet Explorer, another is one session with the Chrome extra. So this is called table, port address table, PATing, port address translation. So this port, any traffic which it will go here on port 80 or port 443. Traffic will go on to the extreme end, like you say HTTPS google.com. So on that port 44 it will reach to the google.com. But this was done from the Chrome, and the second was again going to hpe.com. So this router will have the table. So when the reply will come from HP, there are two replies. I will generate like this. So one goes from that side and one goes from this side. So this is the one. Another one, and the earlier one is suppose this one. So when the reply will come, so automatically it will bring that reply to this port, and this port will take the reply to respective browser. So this table will go on generating. Also there will be another table for suppose port number 64004 and 64005 and so on, whatever is that. It may have multiple sessions, it may have 10 browser sessions, and this. So this table will grow. Sorry. Okay, this table will grow, and when this table will grow, 64010 64011. So this is called port address translation, and this will fill up the RAM of your router. If router is falling short in the RAM, this will mess up and your traffic will get hang, and you will not get right response. You will search browser, it hangs, khalas. Why? Because there is a RAM. In that condition, you have to increase RAM onto the router. Where the port address translation takes place? Inside the RAM of router. So very important, remember, because at the end, all the traffic will go where? This all will go to the same destination and same IP. This will also go to there. So whenever you go outside, you will see only one IP. Single IP seen from outside. So this is what I have explained you, what is port address translation and NATing, which people have asked. Now I will, I hope you will have all clear picture, and I will come to my slide. I have cleared and covered our topic. Next topic will be from VMware, ESXi installation and VM creation. And thank you for watching. Kindly share and subscribe my channel, Ulde Sir. As you know that you have to, somebody your tech can give. I don't want anything, you just share and subscribe. That will be good. Thank you.